If f of x is 3 sine x plus 2 cos x, then find the second derivative. Okay, I see what's going on here. Well, the first derivative is going to be 3 sine x, so the derivative of sine is cosine x, plus 2, the derivative of cosine x is negative sine x. So let's clean that up a little bit. Derivative numero uno is going to be 3 cos x minus 2 sine x. Okay, now the second derivative is just me taking the derivative of that guy right there. So the derivative of 3 cos x is going to be 3 negative sine x minus 2 cos x. And cleaning that up a little bit is just going to be negative 3 sine x minus 2 cos x. And that, boys and girls, is all she wrote. There you have it. Dunzo. If y equals x minus 5 over x, then d squared y over dx squared, what is that? Oh, that's the second derivative. All right, so let's find the first derivative. And let me just rewrite out y because I'm going to need the space. Y equals x over 5 minus x. In order to find the first derivative, I need the quotient rule. So you're my u, you're my v. Quotient rule is u prime v minus v prime u all over v squared. Okay? U prime is going to be the derivative of the numerator, which is 1. V prime is going to be the derivative of the denominator, which is 1. And v squared is going to be the denominator squared, x squared. So dy dx, the first derivative, is going to be u prime, which is 1, v, which is x, minus v prime, which is 1, u, which is x minus 5, all over v squared, which is x squared. All right, so let's see if anything magical happens. Let's see if we have some simplifying going on. 1 times x is x, so let's distribute negative 1 here. So minus x, that's nice, plus 5, all over x squared. So derivative number 1 is going to be that 5 over x squared. Now to find the second derivative, I have to do the quotient rule again. No, I don't. I'm going to be clever here. I'm going to be smart. I went to college. I'm going to do this. I'm going to write dy dx like this because I can. 5x to the negative 2. And then I'll do power rule so I don't have to do quotient rule. Look at me being smart. Let me drop that negative 2 down. Okay, so d squared y over dx squared, or the second derivative, is going to equal negative 2 times 5, which is negative 10, x to the negative 2 minus 1, which is negative 3, and then that simplifies out to negative 10 over x to the third. Oh. So that started out looking like, oh, this is going to be a problem, quotient rule twice, and it could have been, but I didn't want it to be by doing it this way, so that's another way of doing it. Fun stuff. Find the second derivative of f of x equals sine x times e to the x. All right, so the first derivative is going to require product rule. So if you remember, product rule is u prime v plus v prime u. And so if I'm looking at this guy right here, u prime is going to be the derivative of sine x, which is just cos x. And v prime is going to be the derivative of e to the x, which is also e to the x. How nice. Now, the first derivative then is going to be f prime of x equals u prime v, so cos x times v, which is e to the x, plus v prime, which is e to the x, times u, which is sine x. So let's clean that up just a little bit. F prime of x equals cos x times e to the x plus sine x times e to the x. Okay? Now, the second derivative, I know what you're thinking. Ugh, product rule and product rule again? Nope. I already know what the derivative of sine x e to the x is because I just found it. So the second derivative, I'm not going to repeat myself by doing the same thing twice. I know that the derivative of sine x e to the x is cos x times e to the x plus sine x times e to the x because I just did it. Okay. What I have to do here, though, is, I'm going to have to do product rule for the cos one, but it's not going to be too dissimilar from what I just did. All right, you're going to be my u and you're going to be my v, so u prime is going to be negative sine x because the derivative of cosine x is negative sine x, and v prime is going to be e to the x, right? So u prime v is going to be negative sine x times e to the x plus v prime u is going to be e to the x times cosine x. And that's all still attached to this guy right here. Okay? Now, wonderful things happen. Negative sine x e to the x, sine x e to the x, cancel each other out. E to the x cos x e to the x are the same thing. So f double prime, the second derivative, is going to be 2 of these cos x's times e to the x powers. And that, ladies and gentlemen, is the second derivative using product rule a buttload of crap of times. Find the third derivative of h of x equals x to the 5th minus 3x cubed plus x. So power rule, power rule, power rule. The first derivative is going to be 5x to the 4th minus 9x squared plus 1. Okay? Power rule, power rule, power rule. The second derivative is going to be power rule, power rule, power rule. 20x to the 3rd minus 18x, you're gone. Third derivative is going to be power rule, power rule. And that's going to be 20x squared minus 18. So a pretty lovely problem, just had to do some math. What is the second derivative of the function f of x equals 3x cubed minus 2x squared plus 6x minus 11 at x equals 2? All right, well, power rule a bunch of times to start us out, right? 3x squared becomes 3x cubed becomes 9x squared, jump the gun. 2x squared becomes 4x. 6x becomes 6, and negative 11 goes away. F double prime is going to be, power rule, again, 1, 2, 3 times. 18x minus 4, 6 becomes 0. Now my job is to find out what happens when x is 2. So f double prime of 2 is going to equal 18 times 2 minus 4. 18 times 2 is 36. 36 minus 4 is 32. So my answer is 32. Nifty! Oh my gosh! If f of x equals sine x, then find the 34th derivative? I wonder if there's a pattern. Well, all right, so let's do this. The first derivative is going to be cos x. The second derivative is going to be the derivative of cos x, which is negative sine x. The third derivative is going to be the derivative of negative sine x, which is negative cos x. And the fourth derivative is going to be, oh, no way, sine x. So this is just going to repeat itself, which means you're going to be the same as the fifth derivative, and you're going to be the same as the sixth derivative, and so on and so forth. So what would the 34th derivative look like? Well, the 34th derivative would basically, if I were to keep this process going, all right, 32 would be like down here somewhere because these are all the multiples of 4. So u would be 32, which means u would be 33, which means u would be 34. So the fourth derivative, 34th derivative, is the same as the second derivative, which is negative sine x. Huh. Interesting. I like it. If xy equals 5, find the second derivative. So this is going to require implicit differentiation. So let's write that out. Xy equals 5. All right, let's d dx both sides. d dx d dx. This is going to use the product rule. So if I have u is x, u prime is going to be 1. V prime is going to be the derivative of y with respect to x, which is 1 dy dx, or just dy dx. The power rule is u prime v, product rule, plus v prime u. All right, so on the left side, I get u prime v, which is going to be 1 times v, which is y, plus v prime, which is dy dx, u, which is x. That's the left side. That's going to equal 5, or the derivative of 5, which is nothing. So over here, I get 1 times y, which is y. So let's write this stuff over here now so I have a little bit more space. Y plus x dy dx equals 0. Let's subtract y from both sides. And x dy dx is going to equal negative y. Divide both sides by x, and dy dx equals negative y over x. All right, no big deal. But I have to take the derivative of again. So that's going to require quotient rule now. So u over v. So u prime would be 1. We'll have the negative attached to u. We'll keep the negative right there. So negative 1, because that does change things slightly. V prime is going to be 1, and v squared is going to be x squared. So the quotient rule, and let me write that up here, is going to be u prime v minus v prime u all over v squared. So d squared y over dx squared, the second derivative, is going to be, oh, did I forget something? I did. When I took the derivative of u, I forgot to attach dy dx. That changes quite a bit. Quite a bit. All right, we're good now. Which means I don't need that 1. Can I get the 1 out of here? Nope, that's the negative. I want the 1 out of here. Nope, that's the d. I want the 1 out of here. Yes, by 1. All right, much better. Okay. All right, let's clean this up. U prime is negative dy dx. V is x. Minus v prime is 1. U is x. No, is negative y. Oh my gosh, this problem's killing me. Over v squared is x squared. Okay. D squared y over dx squared equals, no, wait a minute. How am I supposed to get dy? How am I supposed to do this? You know what? I know what dy dx is because I found it over here. Dy dx is negative y over x. So why don't I just replace those? Oh, how nice. And that allows these x's to cross out. Okay, so that's going to make life a little bit easier. Minus 1 times negative y is going to be plus y. Ooh, wonderful things happen. Over x squared. D, the second derivative, is going to equal negative y plus y over x squared, which is 0, over x squared, which is 0. Wow, who would have thought? Not me. I never would have thought. But the second derivative gives you 0. Interesting.